Recording. All right. So we may as well begin then. So I'm sharing my screen with you, and you should be able to see it's called additional probability problems. Sorry, that's for the other version of the course, but it's the same exercise that I gave all of you. So let's work our way through this. And if you have any questions or concerns, just let me know as we work our way through this, okay? So number one, so notice that for the probability exercise, I give you earn problems, dice problems, and card problems. That's pretty standard, all right? So we'll start off with the earn problems. Number one, so suppose you have an urn and you have 10 balls in the urn altogether. You have 4 red balls, 2 green balls, and 4 orange balls. Let's say that you make 3 draws in the urn, but this time without replacement, okay? So if it's without replacement, that means that the probability of the second event depends on the probability of the first, right? So the events are not independent of one another, all right? So number A, what are the odds of getting no red balls? And so if you look here, now, by the way, on the midterm, it's okay if you just put your answers like that. You don't, I mean, if you want to use a calculator and give me a fraction answer or a decimal place, that's up to you. But you don't really need to. To get full marks, you just need to give us the, what I have here, okay? So what are the odds of getting no red balls? So remember, we're drawing 3 times without replacement. So I draw the first time, right? There are 10 balls in the urn when I draw the first time. Now that I've drawn a ball, when I draw the second time, there are only 9 balls in the urn, right? Then when I draw the third time, there are only 8 balls in the urn, okay? Now, now the question is, what are the odds of getting no red balls? Well, we know that there are 6 non-red balls in the urn, right? 2 green balls and 4 orange. So I draw the first time, my chances of getting a non-red ball is 6 out of 10. Now that I've drawn, there's 1 less ball in the urn. So now there are only 9 balls. And because I already drew a non-red ball, that means there are only 5 non-red balls left. So now it's 5 out of 9, right? And then finally, for the third draw, there are only 8 balls in the urn, right? And now there are only 4 non-red balls left, right? And so now the probability is 4 out of 8. So overall, the answer is 6 out of 10 times 5 out of 9 times 4 out of 8. If you do the math, it's what, 30 times, so 120 out of 720. All right, is everybody good with that? Okay, we go now to number B. What are the odds of drawing exactly 1 red ball? Okay, so exactly 1. That means that you're drawing 3 times, but in the 3 times that you're drawing without replacement, you only get 1 red ball, okay? So then there are 3 possibilities. I draw the first time and I am successful and I get a red ball, then the chance of getting a red ball are 4 out of 10. I draw the second time and I don't get a red ball, and there are 6 non-red balls, so that's now 6 out of 9 because there's 1 less ball in the urn. And then I draw a third time, there's even 1 less ball in the urn, and now there are only 5 non-red balls, right? And so it's 4 out of 10 times 6 out of 9 times 5 out of 8. I use times multiplication because we're talking about these are probabilities that are cumulative, right? So this is the overall probability, the conjunctive probability, and each of those 3 scenarios are disjoint. So it's so multiplication for each of the 3 scenarios, and then addition to put the 3 scenarios together. So it'll be 4 out of 10 times 6 out of 9 times 5 out of 8 plus 6 out of 10 times 4 out of 9 times 5 out of 8 plus plus 6 out of 9, 6 out of 10 times 5 out of 9 times 4 out of 8. All right, so that's why I have 3, and there are 3 possibilities altogether. Okay, so that's getting exactly 1 red ball. Now, what are the chances of getting exactly 2 red balls? Well, in this case, that means that in across the 3 draws, I will get 2 red balls, okay? So Same kind of thing here. First time I draw, I get, let's say I'm successful, I get a red ball, so that's 4 out of 10. The next time I draw, there's one less red ball in the urn, and there's one less ball in the urn, so now it's 3 out of 9. And then now that I've drawn my exactly 2 red balls, there are only non-red balls left, and there's 6 of those, and there are 8 balls left in the urn. So it's 4 out of 10 times 3 out of 9 times 6 out of 8, 3 times, right? Okay, so 4 out of 10 times 3 out of 9 times 6 out of 8. Let's say, and then we get, I don't know, 3, and then 6 out of 10 and 4 out of 10, 4 out of 9 and 3 out of 8. And then the other scenario is 6 out of 10 and let's say 3 out of 6 out of 10, then 4 out of 9 and 3 out of 8. Okay. So anyway, but the point is there are 3 scenarios, right? And so that's why I have 3 times each of those 3 scenarios. Okay. The scenarios differ in terms of the order in which you draw the exactly 2 red balls. Okay. Now we go to D. What are the odds of getting exactly, sorry, my apologies, of getting at least 1 red ball? Okay. Well, what does that mean exactly? Getting at least 1 red ball means that, so if I, sorry, is that, yeah, at least 2 red balls, all right? So that means 4 out of 9 times 3 out of 9 times 2 out of 8, right? And that means that I get, in this case, let's say all red balls. So at least 2 red balls means all red balls or 2 red balls, right? All red balls and exactly 2 red balls. And so the other part of it, 3 times 4 out of 10 times 3 out of 9 times 6 out of 8, that's the chance of getting exactly 2 red, okay? Number E, what are the odds of getting at most red ball, 1 red ball? Well, that means then that there are 2 possibilities. I'm drawing 3 times, and my chance of getting at most 1 red ball means that either I get no red balls on my first draw, or I get exactly 1 red ball. So the chance of getting no red balls, right, would be 6 out of 10 times 5 out of 9 times 4 out of 8. And the chance of getting exactly 1 red ball would, of course, be 4 out of 10 times 6 out of 9 times 5 out of 8. And there are 3 different possibilities depending on when I draw the red ball. Okay, so those are how you do the urn problems. Okay. All right. Any questions? Everybody good? Okay. All right. Okay. So I'm just going to assume that this is okay. Okay. So let's go now to problem number 2. So problem number 2 are the dice problems. And as you know, when you roll dice consecutively or simultaneously, those rolls are independent of one another, right? Assuming that the dice don't strike each other, then all of those rolls are independent. So that means then that you're not going, anyway, so, all right, so it's different than the urn problems. In the urn problems, it was without replacement, so those events depended on one another. But in the case of the dice, assuming that they don't, hit each other when you roll them, then that means that those events are independent. So what are the odds of getting exactly 2 ones? Well, the odds of getting exactly 2 ones are getting 1 on the first, 1 on the second, and then a non-2 on the third. So it's 1 out of 6 times 1 out of 6 times 5 out of 6, and it's 3 times, right? Because the order can differ. For example, the next one might be 5 out of 6 times 1 out of 6 times 1 out of 6, or it might be 1 out of 6 times 5 out of 6 times 1 out of 6. What are the odds of getting only ones? That means you're going to get 3 ones, all right? Well, there it's 1 out of 6 times 1 out of 6 times 1 out of 6, all right? And those events are all independent. So notice that the denominator does not change, all right? And notice that we're using multiplication because those are conjunctive events. The addition is used for so-called disjunctive probability events. These are conjunctive events, all right? Okay, and just to do the math, if you want, 1 out of 6 cubed is what? So out of the 216 possible rolls, only one of them has all ones, right? Okay. All right, what are the odds of getting a total of 11? So what you're going to do is just add together all the possibilities. So to get 11, one way of getting 11 is getting 2, 3, and 6 in any order. There are 6 ways to get 2, 3, 6 in any order. So you get 6 times 2, 3, 6. Then you could get 11 by getting 1, 4, 6, and there's 6 ways to do that. So it's 6 times that. Then you could get 3, 3, 5. That adds up to 11. There are 3 ways to do that. You could get 4, 5, 2. There are 6 ways to do that. There are you could get 3, 4, 4. There are 3 ways to do that. You could get 1, 5, 5. There are 3 ways to do that. So you add them all up. It's 27 times 1 out of 216, or 27 out of 216. Okay. Now, for number D, what are the odds of getting at least 2 ones? Well, if I get at least 2 ones, that means I'll get either exactly 2 ones, and there are 3 ways to get exactly 2 ones, right? Or I'll get all ones, and that's 1 out of 6 times 1 out of 6 times 1 out of 6. Number E, what are the odds of getting at most 2 ones? Well, that means if I get at most 2 ones, I'm going to get no ones, or I'll get 1 1, or I'll get 2 ones. But I can't get all of them once, right? Because it's at most 2. So there's only one way to get all ones. And so it's 1 out of 216. So then it will be 1 minus 1 out of 216. Okay. Any questions on the dice problems and how I got those? Okay, great. Okay. So if you have any questions, just please feel free to ask. Christina, do you have your hand up? How can I help you?
Hi, Dr. McPherson. It's Christina and Caitlin, actually. We had a class go until 5:20, so we
That's
figured
okay.
we'd join together
Oh,
just so
sure.
we
Yeah,
could make it on
that's no
time.
problem. That's no problem.
Great. Thank you. So I believe Caitlin just had a question for
I
you.
just wanted to ask, since we were kind of doing a probability question just before, if you would want us to use like the formulas that you provided us with in like your lectures and on the slideshows, or if we could just do like, as I know our GA taught us a different way where we could just use like just basic fractions, like, and figure it out using like, instead of a formula, just like breaking down the question and kind of like.
Well, I guess what I'm insisting that you use the formulas, right? So that are in the appendix. So when I post the test, you'll see that in the appendix there are formulas. I want you to use those particular formulas to make your calculations, and I want you to show your work too. So you have to show your work, and I want you to use the formulas. Now, maybe your GA gave you a way to get, a shorter way or something like that. That's okay. I have no problem with that. But for purposes of the test, you have to use the what's in the appendix.
Okay, thank you.
Yeah, no problem. Everybody else is good? Okay. All right, great. Always interrupt if you have questions. Okay, so let's then go back to the probability problems. So now we have number 3, the card problems. Okay, so again, just like for those of you that joined a little bit later, that's all you have to do for the probability problems. You don't need to calculate the exact values. I just want to make sure that you know how to use the rules, right? And so all you have to do is put the answers in the form that I have them on this assignment. So the next one then are card problems. So there are 52 cards in the deck. All right. And, now if they're jokers, then there are, I think, 54, right? But generally, but we're just assuming that the deck doesn't have any jokers. And maybe I can put that in the stem to make sure everybody's clear on that. So assuming there's no jokers, there are 52 cards. I draw from a randomized deck of cards 3 times in succession. When I draw a card, I do not replace it. What that means is that each time I draw a card, it's dependent on the prior event, right? So these are dependent events. They depend on one another. So the first question is, what are the odds of getting at least 1 ace? Okay. So in that case, you can use the complementation rule, and it's basically, so here's the thing, right? To get at least 1 ace, so that means you're going to get 1 ace, or you can get 2 aces, where you get 3 aces, right? Because you're drawing 3 times. That means that there will be no draw where you'll get no aces. So what I'm doing is I'm using the complementation rule. I subtract the chances of getting no aces from 1. Okay, so it's 1 minus, and then all of these, right? So what you're seeing there, 48 out of 52 times 47 out of 51 times 46 out of 51, all of that is the chance of getting no aces, right? So I subtract that from 1 using the complementation rule, and so it will be whatever the probability is, right? Whatever that works out to be arithmetically. Number B, what are the odds of getting at least 2 aces? That means that I'll get either exactly 2 aces or exactly 3 aces. So one way to calculate it then, what are the chances of getting exactly 2 aces? Well, that's 4 out of 52 times 3 out of 51, right? Those are aces. And then 48 means that there are 48 non-aces divided by 50. Notice that the denominator decreases because I'm not replacing the cards, right? Ooh, so that's one possibility. Another possibility is I get all aces. Then that's 4 out of 52 times 3 out of 51 times 2 out of 50. So when you add those two together, those are the chances of getting at least 2 aces. All right. What are the odds of getting at most 2 aces? Well, if I get at most 2 aces, that means that I can't get all 3 aces, right? So what I do is I subtract from 1 using the complementation rule the probability of getting all aces. All right. Well, the probability of getting all aces is 4 out of 52 times 3 out of 51 times 2 out of 50. And I subtract that value from 1. Number B, what are the odds of getting either no kings or no queens? So either you're going to use the disjunction rule, and disjunction involves adding. Okay. So in other words, there are 2 possibilities. I get, let's say, no kings, or the other possibility is I get no queens. All right. So the chance of getting no kings is 48 out of 52 times 47 out of 51 times 46 out of 50. The chance of getting no queens, again, are 48 out of 52 times 47 out of 51 times 46 out of 50. So those are the 2 possibilities, right? Either no kings or no queens. So I add those together, and that will give me my answer. Okay, so now what are the odds of getting either all aces or all jacks? So I draw 3 times, and the only cards I get are aces. Or the other possibility is I draw 3 times and I only get jacks. Again, you're going to add those 2 probabilities together. So the chance of getting all aces, that again is going to be 4 out of 52 times 3 out of 51 times 2 out of 50, right? That's the chance of getting all aces. There are 4 aces in the deck, right? And by the way, so for face cards, there are 4 of each face card. There's 4 queens, 4 kings, and 4 jacks. So then the probability will simply be 2 out of times 4 out of 52 times 3 out of 51 times 2 out of 50. All right. So those are the kinds of problems that I'll give you on the actual midterm. It'll be of that type there. And so before I move on to the sample midterm, I just want to see if anyone has questions. Okay, I see Ellie, I believe is the name. And I'll get to you in a second, Christina. You said for 3D, we use the mutually exclusive disjunction rule, but wouldn't no kings or no queens be not mutually exclusive, right? Well, I mean, actually they are. If you get no kings, that's completely different than getting no queens, isn't it? Right? As far as I know, you either get no queens or you get no kings. So those are mutually exclusive events. Okay, so did someone else have their hand up now? I saw Christina and then Nadia. So Christina, how can I answer your question?
Hi, we were just wondering if when we give our answer for the probability questions, would you want it in simplest form or no? Because
Yeah.
we even talked about that with our GA in our class, because the answers that you had, like, were technically the same that we got, but we would simplify it into its simplest fraction.
Well, I guess that's okay as long as you can show to me or the graders, that you're as long as you can show to us that you know how to use the rules. If you want to simplify, I guess that's okay.
Okay,
That's
because I
up
didn't
to
know
you.
if there would be like a multiple choice answer where it has like all the fractions, but we
Oh,
put
oh,
like
no.
the simplest form,
Well,
and it's
in,
actually you don't want it to be in the simplest form, and that's one of the answers.
yeah, no, I'm glad you asked that. First of all, it's not multiple choice, right? This whole exam is going to be free response. So it's just like you're writing a class or a test in class, using a pen or whatever. So there's no multiple choice at all, right?
Oh, okay, thank you.
Yeah, it's all free response. And I was it Nadia or someone that had their hand up? Yes. Okay. So who else has their hand up then? Can I help you? Let's see. Someone called Nadia, I think, had their hand up, but are you okay now? Is everybody good? Okay. So I assume then that there are no questions on that. All right. So now what I want to do is move to the sample midterm, and let's work through the sample midterm, okay? So let me what I'm going to do is I'm going to stop sharing for a second, and then I'm going to restart sharing again with the sample midterm. So first of all, I'll stop sharing that. Okay. And let's see now. So I'm going to go back here. And on my screen, I'm going to open up the sample midterm. So just give me a second. Okay, so that's up. So now I'm going to start sharing that. So I'm going to screen. Okay, so hopefully everybody sees that. Okay, so this is a sample midterm, and this basically is what your actual midterm will look like. It'll have the same number of questions, same level of difficulty. Okay, so that's why I wanted to give you a sample midterm. It gives you a good idea of what to expect on the actual test. So let's see what we have here. So the first question, I'll give you two little mini arguments, and then what you do is you do the what are called the scriven diagrams. Okay, so let's look at number one. Now, what I will do on the actual midterm, just like on the sample midterm, is I will number all of the distinct phrases, all right? And you'll use that numbering when you draw the diagram, okay? So first of all, number one, the economy is in trouble. Why? Well, why is a premise indicator. That means that what follows will be the reasons for why the economy is trouble. So first of all, the economic system is in distress. And then it says because. So because is a premise indicator because consumers spend less. So that means that 3 is a premise for 2, and 2 is a premise for 1. And so if you notice on the diagram, then you have 3 arrow 2, 2 arrow 1. All right. So that's now there's another claim being made in number 4. Democracy is also in trouble worldwide. That's a separate argument, right? One argument is to support the claim that the economy is in trouble. The second argument is to support the claim that democracy is in trouble. All right. So why is democracy in trouble? Well, first of all, democracy is declining in China. Even in the United States, democracy is on the decline. Moreover, Russia is no longer democracy. So that seems to show, if you put those three together, that seems to be a pretty good reason for saying that worldwide democracy is in trouble, because those are three major countries, right? And so therefore you put 5 plus 6 plus 7. They depend on each other. They conjointly support the conclusion 4. Now, remember that in terms of counting the arguments, the number of arguments are the number of conclusions, right? So notice here that 2 is a conclusion from 3, 1 is a conclusion from 2, 4 is a conclusion from 5, 6, and 7. So therefore, that means there are 1, 2, 3 arguments present, right? Okay, now there's another little argument below. So number 1, listening to classical music is important. Okay. 2, listening to classical music makes a person happy, and happiness is important. So those seem to be the reasons why listening to classical music is important. It makes people happy, and being happy is important. So therefore, I say 2 plus 3, 2 and 3 conjointly support 1. Now, another claim, it's a separate claim, is that eating the right food is important. Why? Well, eating the right food makes a person healthy, and being healthy is important. So that means that 5 and 6 conjointly support 4. So remember that the number of arguments equals the number of conclusions. So there's a conclusion here, and there's a conclusion in the other argument. So there are two arguments present altogether, right? So is everybody good with that? Okay. Okay, I don't see any questions, so it looks like we're good with that. Okay, good. All right. So let's now go to number 2. Okay. So now remember that what we did in the course, towards the beginning of the course, is we found out using the principle of charity how to identify conclusions in deductive arguments. And so you did that by trying to put the argument into one of those, 5 or 6 or whatever valid argument patterns. And by the way, all those are in the appendix and they're in the lecture notes, of course. So let's look at this argument. Climate change is real. If temperatures are rising worldwide and glaciers are melting, then water will continue to rise. If water levels continue to rise, then climate change is real. So then it follows. So if you then now add the premise that temperatures are rising worldwide and glaciers are melting, those are the antecedents of the two conditionals. So then you can infer the consequence of the two conditionals, which is that climate change is real. Okay. So that's how it works. Again, temperatures are rising worldwide and glaciers are melting. And if you put that together with if temperatures are rising worldwide and glaciers are melting, then water will continue to rise. So then you get water continues to rise. That's by modus ponens, right? Then if water levels continue to rise and climate change is real, right? Well, that by modus ponens gives you climate change is real. All right. And so there's the argument. So climate change is real is the conclusion. And so you could put that either you use modus ponens twice or you used hypothetical syllogism. Remember, hypothetical syllogism is if P then Q, and if Q then R, then if P then R, right? That's called a hypothetical syllogism. All right. We go to number B. Here's the argument. All Accords are worth buying. All Hondas are reliable cars. All Accords are Hondas. All reliable cars are worth buying. Okay, so these are all statements. When you have all statements, it's going to be a universal syllogism, right? Remember, universal syllogism: all A's are B's, all B's are C's, all A's are C's, right? So this is a universal syllogism. So first of all, you have all Hondas are reliable cars, right? And you have all Accords or Hondas. If you put those two together, you by what is called universal syllogism, you get that all Accords are reliable cars, right? Now, you have all reliable cars are worth buying. So if we know that all Accords are reliable, then we also know that they're worth buying, right? Because we have all reliable cars are worth buying. So basically, that's universal syllogism, right? All A's are B's, all B's are C's, therefore all A's are C's. So the conclusion then, so I hope it shows up. I have it in orange. That's the conclusion. Then number C, same exercise. You're going to have to tell me what the conclusion is. So here we have 4 statements. We have all mammals are animals, all humans are mammals, right? If you put those two together by universal syllogism, you get that all humans are animals. Now we know that Socrates isn't an animal, then it would follow by predicate instantiation that Socrates isn't human. So I would accept either predicate instantiation times 2, or if you want, you could say combined universal syllogism and predicate instantiation. Okay. And so that's how you use the principle of charity to identify conclusions and arguments that don't use, yeah. Okay. So how is that? Is that good for everybody? So again, so it tells you that's in the absence, by the way, of conclusion or premise indicators, right? Okay, so far so good then. All right, I don't see any questions. So the next one, it's a similar type of exercise, except now I want you to identify the missing premise. So these are arguments where you don't have the missing premise, right? So if you look on here, I have the missing premises in red. So here's number 3. For the following incomplete deductive arguments, add exactly one premise and indicate which valid argument pattern the resulting completed argument most closely fits. So it's the same kind of task as in the previous one, except this time I'm asking you to actually point out to me what the missing premise is. Okay, so if you look here, I have either it is raining or it is cloudy. So either it is humid or it is snowy. The most obvious missing premise is if it is raining, then it is humid. And if it is cloudy, then it is humid. And notice that that's constructive dilemma, right? So constructive dilemma is if P, then R, and if Q, then S, right? And then you have whatever it is, P or R, then you get Q or S. So basically, the missing premise here to give you the conclusion, which is either it is humid or is snowing, is if it is raining, then it's humid, and if it is cloudy, then it's humid. So that is called that's called constructive dilemma. Okay. If we go to number B, I have it didn't rain and thus it isn't humid. Okay. So now you need to add in the missing premise. Well, the most obvious missing premise is if it is humid, then it rains. Then by modus ponens, you get it isn't humid because you have it didn't rain. All right. So modus tollens is your best bet there. I suppose you could also use modus ponens. In other words, if it didn't rain, then it isn't humid. And, if it didn't rain, then it isn't humid. Then that would be, you would get the conclusion by modus ponens. And that would be your missing premise. Okay. The last one in this section, all mammals are animals. Bubbles is a mammal, thus Bubbles is mortal. So everything is there except we're missing the term mortal, right? So we need to add in a premise that will give me Bubbles is mortal, that contains the word mortal. So we have all mammals are animals, all animals are mortal. By universal syllogism, you get that all mammals are mortal. Bubbles is a mammal, Bubbles is mortal. So it's universal syllogism and predicate instantiation. Remember, predicate instantiation is all A's are B's, X is an A, thus X is a B. Okay, so is everybody good with the missing premises and with identifying the conclusion? We're good? Okay. All right. All right, moving on to number 4. You have the definition. So this is pretty easy stuff. Let's face it, this is pretty easy material here. So everybody should get, I would think should get perfect on number 4 and 5. So for each of the following definitions, classify them as either intentional or extensional. So remember from the lecture, right, that an intentional definition gives a list of properties that something must satisfy to be denoted by the term. Whereas the extension of the term are all the things denoted by the term, right? So I want you to tell me for each of these 3 definitions, whether they're intentional or extensional. And then remember that for intentional and extensional, they're different kinds. So for example, for extensional, there is ostensive definitions, there are quasi-ostensive definitions, there are definitions by subclass, definitions by example. For intentional definitions, you have operational definitions, you have genus and difference definitions, you have etymological definitions, and you have synonymous definitions, right? Okay. So if we look at the first definition, number A, the English word canine has its origins in the Latin term canis. Well, that clearly is looking at the etymology of the term. So all etymological definitions are intentional, and typically you would find that kind of a definition in a dictionary, so we say it's lexical, right? So if you look at a dictionary, like an old-fashioned dictionary like Webster's or whatever, or Oxford Dictionary, whatever it might be, basically they will always have the etymology of the term, right, before they give you the actual definition. Okay, number B, PV equals nRT. I'm sorry to haunt you with, introductory university chemistry or high school chemistry, but that's just from chemistry. Pressure times volume equals N times R, which is a constant, and T. N is N Avogadro's number? I'm not quite sure, but anyway. So the point is that it's an equation, and typically equations are given for the purpose of making predictions, right? So it's theoretical. For example, if I know that the pressure is high, I know that the temperature is high. If I know that the volume is high, then I know the pressure is low, right? So basically it allows me to make predictions. So it's theoretical, that's the use. And synonymous definitions, because it's an equation, right, are typically intentional. So it's intentional, synonymous, theoretical. All right. So on the midterm, that's all I want you to do. You don't need to tell me why you think it's those. It's a very non-writing intensive question. Number C, a house is defined as any structure where people live. All right. So that's the definition. I'm not asking you to evaluate it. Just tell me if it's intentional or extensional. Well, I think it's pretty clear that we're listing characteristics of what it is to be a house. So it's definitely intentional, and it's genus and difference. Why is it genus and difference? The genus is the structure, and the specific difference is where people live. So it's intentional, genus and difference, and it's the kind of definition you would find in a dictionary. So you can say lexical, or I would also accept precisely. It's making the term more precise. Okay. And then what I'll also do on the midterm is I'll give you 5 little mini definitions like we have here, and just ask you to tell me what the problem is with it, right? So if you look at 5A, light is the emission of light packets called photons, all right? Notice that light occurs in the definition itself, but that's the term I'm trying to define. So the definition is circular, right? So that's R1. Number B, a race car is any vehicle not used for transportation. All right. Notice the word not. So typically when you have a not, that means the definition is negative. So that's R4. It's also too broad because there are a lot of vehicles not used for transportation that are not race cars, right? So, for example, people that are into classic cars, they'll soup them up and they'll make them look really nice, but they never drive them, right? So, so it's either negative, I would take that, or I would take too broad. Number C, wine is any fermented beverage. Well, there are a lot of fermented beverages. There are beer, whiskey and stuff like that. So clearly that definition is too broad. There are a lot of fermented beverages besides wine. Number D, a horse is a 4-legged animal in the class Equus. Okay. Now that definition is too broad. For example, and I looked it up, by the way, just to let you know, I did look it up. The word, the class Equus in taxonomy includes not just horses, but also zebras. I'm sure you're familiar with zebras, right? So zebras also fall into the class Equus, so the definition is too broad. Okay. And the last definition is that a triangle is any 3-sided polygon, one of whose angles is 90 degrees. Okay, well, sure. I mean, all triangles are 3-sided polygons, but it's too narrow because something can be a triangle without one of its angles being 90 degrees. I mean, what I've just done is I've defined what a right angle triangle is, right? But I have not told you in general what a triangle is. A triangle is any 3-sided polygon, all of whose angles equal 180 degrees. So the definition is too narrow, okay? Oh, sorry about that. I didn't mean to minimize the, okay, so is everybody good with that? I'm just going to make sure, does anybody have any questions or concerns or anything? Okay, so far so good. All right, great. Okay, so we're good. All right, so let's go then to question number 5. Sorry, number 6, my apologies. Okay, so now we go on to the next set of questions, number 6. So remember I had a lecture on inductive arguments, right? How to identify inductive arguments. I don't believe I have any questions on the midterm that ask you to tell me whether an argument is inductive or deductive. I just didn't put it on the test, so don't worry about it. All right. But part of that lecture also had to do with seeing whether or not something can be strongly inductively inferred from a passage. So remember that if you have a statistical passage, you're going to have a confidence level and a margin of error, right? So in this particular survey, the confidence level is 95% and the margin of error is 2%. So that means that this survey is accurate, it obtains between minus and plus 2% 95% of the time. So that's a very high confidence level. So you can be pretty confident that what you infer from this is probably correct, right? Okay. So all that I want you to do there, you don't need to explain it. Just tell me whether the sentence is strongly inductively supported or weakly inductively supported. And remember that when you determine that, you have to take into account the margin of error. So let's look at number A. Most Canadians are either liberal or conservatives. Okay. If we look at the passage, it said that 30% of the people interviewed said they are liberals, and 28% said they are conservative. So let's take the margin of error for each of them. 26% is the lowest, and 28% is the lowest. So if my math is correct, 28 and 26 is 54, right? So that means then that most Canadians really are liberals or conservatives. And I'm assuming that they're being truthful in what they say, right? Well, that's just an assumption. So then I think it's safe to say that conclusion is strongly inductively supported. Okay, again, taking into account the margin of error of 2%. Number B says at least 23% of Canadians have no party affiliation. Now, according to the survey, 25% said they have no party affiliation. Taking the margin of error, that means the lowest it could be within at a 95% confidence level is 23%. So it's safe to say then that at least 23% of Canadians have no party affiliation. And so we say that number B is also strongly inductively inferred or supported. Okay, so far so good. Now let's go to number C. Roughly 25% of Canadians do not vote in federal elections. If I go to the passage up here, it says that some people have no party affiliation, but it doesn't mean that they don't vote, right? A lot of people will vote in an election, but they may not be affiliated. A lot of people, for example, when they vote, they'll vote for the person rather than the party, right? So that statement is weakly inductively supported by what's in the passage, okay? Now let's look at number D. Less than 20% of Canadians are New Democrats. So let's take a look here. It said that 17% said they are New Democrats. And what does that one say there? Less than 20%. So taking into account the margin of error, let's say it's as much as 19%, it's still less than 20%, right? So therefore, D is strongly inductively supported. And lastly, number E, there are more Canadians who are liberals than there are Canadians who are conservatives. Well, let's see. So how many Canadians again say they're liberals? 30%. That means it could be as little as 28%. And how many people say they're conservatives? 28%, but it could be as much as 30%. So we can't infer from that there are more Canadians who are liberals than there are Canadians who are conservatives. And the reason is because we're taking into account the margin of error, right? Okay, is everybody good with that question? Any questions or concerns? Okay, that's great. All right. So the next thing I'm going to ask you to do, this is the probability stuff. That's what we just did in those little exercises, right? So suppose you roll 3 dice simultaneously and none of them touch each other, right? That's just to make sure that they're independent. Calculate the following probabilities using the probability rules. So again, in your answer on the midterm, I want you to use the rules that are in the appendix, right? Okay. Even if some of your GAs gave you a simpler way, it doesn't matter. For one thing, I'm not looking for the numerical answer anyway. I'm just looking for that you know how to use the rules, right? Okay. So number 8, what is the chance of getting getting no 1s and no 6s? Well, then that means that the chance of getting no 1s, no 6s is for any particular row 4 out of 6, right? Because there are 4 other numbers left. And if I roll 3 dice simultaneously and I don't get any 1s or 5s, then it's going to be 4 out of 6 times 4 out of 6 times 4 out of 6. Notice that you're using multiplication because this is a conjunctive event, right? Okay. Now let's go to number B. What are the probability of getting, and remember too, these events are all independent, right? What is the probability of getting at most 2 1s? Well, okay, that means that if I get at most 2 1s, that means I'll get no 1s, or I'll get exactly 1 1, or I'll get exactly 2 1. The shortcut is to use the complementation rule. Notice here that the chance of getting at most 2 1s means that I can't get all 3 1s. So I subtract that from 1. So the chances then of getting at most 2 1s turns out to be 215 out of 216, right? Okay, what is the probability of getting a total of 6? Well, that's okay. So there are 3 ways of getting a total of 6 altogether, right? So I could get 4 1 1 or 1 4 1 or 1 1 4. So there are 3 ways to get 4 1 1. Or I could get 3 2 1. There's 6 ways, right? I get 1 2 3, 1 3 2, and so on and so forth. There's 6 ways to get that. or I could get all twos, right? There's only one way to get all twos. So if you add those together, right? So it'll be 1 out of 6 times 1 out of 6 times 1 out of 6, which is 1 out of 2, whatever it is, 256 times 3, right? So it's going to, anyway, it's going to be 10 out of that. Actually, you know what? That should be 216. That's a typo. I'll correct that, but that should be 1 out of 216. And also the 1 in D is a typo. It again should be 6 out of 216. So my apologies for that. I'll correct that. Okay. The probability of getting 1, 2, 3 in any order, well, that means I could get 1, 2, 3. I could get 3, 2, 1. I could get 2, 3, 1, and so on and so forth. There are 6 ways to do that. So it's going to be 1 out of 6 times 1 out of 6 times 1 out of 6, 6 times, 6 out of 216, not 210. And finally, E, the probability of getting either all 2s or all 6s. Notice that or is a disjunctive event, right? So the chances of getting either all 1s or all 2s would be, and actually that should be addition. So again, that's a typo. That should be 1 out of 216 plus 1 out of 216, right? So 2 out of 216 are the chance of getting either all 2s or all 1s. So again, I'll correct that. I'm going to post the answer key, right? So I'll correct that when I repost the answer key to the sample midterm. Okay, so 3 typos. In C, it should be 10 out of 216. D, it should be 6 out of 216. And E should be 1 out of 216 plus 1 out of 216. Or 2 out of 216, okay? So those are the probability problems. And if everybody's good with that, then we'll go on next to the fallacies. Okay, so let me see any questions or concerns. Okay, looks like everything's good. All right. Okay, so now let's go to the fallacies. So those are, I mean, let's face it, the fallacies are pretty easy, right? All you have to do, it's, again, if you've noticed that this test is not highly writing intensive, right? It's very short and to the point. It won't take you a long time to write it. You've got lots of time, maybe write one section one day, another section another day, but it's all free response and the answers are very short, right? It's not a lot of writing or anything like that. Okay, so now the last 3 questions, 8, 9, and 10, are on the fallacies. In the lectures, in the online lecture, we looked at fallacies of relevance. We looked at fallacies of of problematic premise, right? So there were more fallacies of relevance than there were problematic premise. I know if I can list them all by memory, but relevance, you had argument from ignorance, composition, division, ad hominem, genetic fallacy, so I can't think of all of them right off the bat, but there are quite a few of the fallacies of relevance, okay? I think straw man and red herring. Yeah, sorry, I forgot those. And then there are the fallacies of problematic premise. There aren't as many of those. There's begging the question. There's, I believe, false dilemma. There's slippery slope, right? So those are, and some others. And so those are the fallacies of problematic premise. Actually, if we might as well just go to the appendix. I have them all listed in the appendix. And of course, it's listed on the lectures. Right, so let's see. So fallacy of relevance, yes. Straw man, red herring, equivocation, I forgot equivocation, argument from ignorance, genetic fallacy, ad hominem. And you have the appeals to motion right. You have to the people, ad populum, division, composition, argument from ignorance. Fallacies of unacceptable premises. You have begging the question, faulty analogy, false dilemma, slippery slope, and hasty generalization or hasty conclusion, okay? Then what we did in the course is I gave you also in that lecture, we looked at what I called additional informal fallacies. We looked at accident, false cause, complex question, inconsistency, 2 wrongs, subjectivism, and suppressed evidence. And we did also, I didn't focus too much on the formal fallacies, but we looked at some denying the antecedent, right? Affirming the consequent, exclusive or fallacy, and illicit predicate instantiation. Okay, so let's just work through 8, 9, and 10, and let's see what fallacies are going on in these questions. So number 8. Here's the first one. It says, number 8, of course there is a God. Almost every civilization in history has believed in a deity of some kind. What I'm doing there is I'm appealing to tradition, right? Ad populum is another charge. So I'm saying, it's like I could say, well, I vote conservative in every election because my parents always vote conservative. That's called an appeal to tradition, right? Number B, since the theory of evolution has no direct evidence to corroborate it, it is most likely a false theory that will one day be discarded. Remember, that's an argument from ignorance. If there's no evidence for something, then it's false. Or if there, that's a version of arguments from ignorance. From the fact that there's no evidence, it doesn't necessarily follow that it's false. It might be true, but we just haven't proven it yet, right? Okay. Number C, Geraldo thinks that students who cheat on exams should not be automatically expelled. I can't believe he thinks cheating is such a trivial thing. Now, here's the thing. Geraldo may think that cheating on an exam is a very serious thing, but it doesn't mean that Geraldo thinks that therefore the person should be expelled, right? I mean, there are a lot of in-between measures there, right? So your best bet there is straw men. You're attributing a view to Geraldo that they don't actually hold, okay? Okay, let's go to the next one. Seeing that the eye and hand and foot and every one of our body parts has some function, it follows that the human body must have a function. Well, that one's pretty straightforward, right? So Aristotle, this is a famous quote from Aristotle, like 2,300 years ago. He says, well, look, the eye has a purpose, right? And the foot and the hand, they each have a purpose. So it must follow that the whole body has a purpose. So that's the fallacy of composition, that what is true of the parts must be true of the whole, right? Okay, number E, some philosophers have argued that all human beings are free to act. If you take any more philosophy, that's a big debate in philosophy, the free will versus determinism debate. However, John is not free since he is in jail, and John is a human being. Thus, not all human beings are free to act. Okay, that's equivocation on the word free. You're using free in two different senses. If I said that human beings are free to act, that's in kind of a metaphysical sense, that we're not determined to act, right? But saying that John is in jail and not free is freedom in the sense of being physically restrained, right? So therefore, it's two senses of the word free, and so we say the argument commits the fallacy of equivocation. Okay, now let's look at the next argument. Okay, so 9. Now what I want you to do in number 9 is identify which fallacies of unacceptable premises the arguments commit. So if we look at A, it says, either we fire this employee for being late or otherwise we were sending a message to our other workers that it's all right to be late. Thus, we should fire this employee for being late. That's a false dilemma. You don't have to fire an employee because they're late. Maybe you could, dock them whatever time they lost, or you could give them a warning. You don't have to fire them, right? Nor are you necessarily sending a message to others if you don't fire them. So therefore, it's a false dilemma. There could be other alternatives besides A or B, all right? Number B, if we allow athletes to take steroids, then their fans will start using steroids. If this happens, then people will begin using all kinds of drugs to feel better or stronger. Eventually, there will be a nationwide drug problem. Thus, we shouldn't allow athletes to take steroids. So I think you would agree there that that's a slippery slope, right? So, if athletes take steroids, then the fans will take them. If that happens, then everybody will start taking them. Then there'll be a nationwide crisis. That's A, leads to step B, leads to step C, leads to step D. That's a slippery slope. That's a slippery slope fallacy. Okay, so far so good. Number C, of course there is a God. Almost every civilization in history has believed in a deity of some kind. Now we saw this argument before. Now in that section, I was looking for fallacies of relevance. In that section, that would be that would be basically an appeal to tradition, right? But now I'm looking for fallacies of problematic or unacceptable premises. So there are two possibilities. If I say, of course there is a God, every civilization in history has believed in a deity of some kind, you could say that I'm begging the question. I'm assuming what I'm trying to prove. Or you could say it's a hasty generalization. Just because every civilization believed in a deity of some kind, it doesn't mean that that deity actually exists. So I would accept there either begging the question or hasty generalization. All right. Number D, Sam is riding her bike in her hometown of Toronto, minding her own business. A station wagon comes up behind her and the driver starts beeping his horn and then tries to force her off the road. As he goes by, the driver yells, "Get on the sidewalk where you belong." Okay, so Sam sees that the car has Quebec plates, and concludes that all Quebec drivers are rude. Okay, every city has rude drivers, right? That doesn't mean that all the people that drive in that city are rude. I think you would agree with me that she made a hasty generalization, right? And the last one in that section, paranormal activity is real because I've experienced what can only be described as paranormal activity. Well, I mean, it's pretty obvious, right? The person is begging the question. They're assuming what they're trying to prove. So your best fallacy charge there is begging the question. All right. Then there'll be one more question, number 10, and I'll ask you to identify either additional fallacies or formal fallacies, right? So remember, the formal fallacies are things like affirming the antecedent, denying, affirming the consequent, rather denying the antecedent, illicit predicate instantiation, um, you know, exclusive or fallacy, stuff like that, right? And then you also have the additional fallacies, like, for example, false cause or complex question, right? All of those. So yeah, then what I want you to do is to indicate which additional or formal fallacies are committed. So number A, you should always play slot machines that no one else is playing. Those machines are most likely to give you a jackpot. Okay. I don't know if any of you have been in a casino, but typically people that play the slot machines will say, well, no one has played that for a while. So maybe that's my lucky machine. Maybe, obviously, the fact that no one has played it has no causal impact on whether you're going to win, right? They're completely independent. And so the best charge here is a false cause. Number B, in Canada, people have the right to free speech. And that's true, the Charter of Rights and Freedoms. Thus, a Canadian should be able to say whatever they like without exception. Well, we know that that's not true. In Canada, we have hate speech laws, right? And rightly so. So what that means is, yeah, I have a lot of things I can say freely as a Canadian person, as a person in Canada under the Charter of Rights and Freedoms, but I can't say anything I want. For example, you can't say, fire in a crowded movie theater if there's no fire, right? There are certain things you're not free to say. So it's a general right, but it's not a universal right. So your best fallacy charge there is the fallacy from accident. Okay. Now we go to the next one. This is number C. If the price of silver rises, the economy is in bad shape. Currently, the economy is in bad shape. Thus, the price of silver will rise. So let's take a look at that. So it's if P, then Q, right? Q, therefore P. That's affirming the consequent. It's a formal fallacy. Now we go to D. All gerbils are rodents. Sam is not a gerbil, and so Sam is not a rodent. That would be illicit predicate instantiation. How do you know? Because you have a universal sentence and then two sentences subject predicate, right? And then the last one, E, people generally like to walk on the beach. I guess that's generally true, right? Beaches have sand, therefore having sand floors in homes would be a great idea. That's the fallacy of accent. Just because in general people like to walk on a beach, it doesn't mean that in all cases they like to walk in sand, right? So it doesn't mean that you have it in your house. So that's the fallacy of accent, okay? And so as you can see from this sample exam, everything you need in terms of rules and stuff like that are in the appendix. So I have all the basic valid argument patterns, right? I have the rules for evaluating genus and difference definitions. I have all the formulas for probability, and I have the informal and formal fallacy. So everything you need is in the appendix. If I forgot to put something in the appendix, let me know and I'll put it in. And also everything's in the lecture notes anyway, right? Everything that you need. Okay. And so that's all of it. So are any questions then about the test? Is everybody feels prepared? You feel that's going to go well? Right? It's not too bad. Yes, Emma Freebus, may I help you?
Sorry, the last question you went through about the sand and the beach, could it also be a false cause? Because they're assuming that that is the reason why they like to go to the beach.
Maybe, yeah. I mean, if you think that you have an alternative fallacy charge, maybe just add a sentence explaining to us why you think it's just as good.
Uh,
Right? Yeah, sometimes there can be more than one fallacy charge for a passage. I myself, I don't see false cause, but if you can explain to me why you think it might be false cause and your explanation makes sense, then we'll give you a full mark. Okay. Other questions? Christina.
Hi, I was just wondering again. I know we talked about this like earlier, but I was just like I was debating whether I should ask it or not. For like the arguments where we have to figure out whether it's like inductively like strong or like weakly inductive or something like that.
Yeah.
Is there like because I know this is also the midterm's going to be different than the assignments online, but online there were like multiple, like the question would say like which one is weakly like inductively
Oh,
strong.
well, yeah, that's because it was multiple choice, right?
Yeah, like the
So
answer.
I mean, so I didn't really have any choice, but
Okay.
yeah, but this is not multiple choice. It's all free response. So you
Yeah,
won't
so
get, 5 options per question.
okay, because I was like wondering, I'm like, because like I remember in that one they would be like, I know like you said it's different, but I still thought I'd ask because in that multiple choice one, it would be like there were I found that there were two answers that were wrong, but one was just more wrong than the other.
Yeah,
So
I mean that's the nature of multiple choice, right? But the good news, I know some people like multiple choice, some don't. The good news for at least some of you is that there's no multiple choice on this test.
okay, so like if we have a question like that, we could just put like we could put both of them and both of them are like incorrect or something or like weakly like inductive or like weak inductive, but one's just more like
Well, you're just looking at one statement each time, right? You're not comparing it to any other statements. You're just looking at that one statement and just tell me if it's either strong or weak.
okay.
Yeah. Yeah. So I know it's kind of confusing, maybe switching from multiple choice to free response, but it's a little bit, the free response would be a little bit different. Do I also see another hand up or no? Right. Okay, so what I'm going to do then, as promised, I'm going to post the test tomorrow. I'll probably post it around noon. All right, and then you just have to get it in by Sunday, by 11:50, whatever I said, 11:59, right? So it gives you basically 4 days. And maybe you've got other tests. We'll work on one section, take some time off, go back to it. It's not timed. It's completely free response. And once you're done all your answers, you put all of them on a Word document, or it can be a PDF, it doesn't matter, and then upload it. Now, I know that for the diagrams, not everybody likes to use the diagram function in Word. If you want to, you could draw it out by hand for the arguments. That's number one, right? And then just make a JPEG of it, and then just upload the JPEG with the rest of your test. But whichever works for you, whichever is best for you. Okay. Okay, sir. Everybody else is okay? All right. So good luck then. I'll post that tomorrow around noon. What I'll also do is I'll post the answer keys that we just went over together. There were a couple of typos on on the probability theory. I'll correct that and then I'll post the answer keys. All right. So good luck, everybody. It's not going to be a super hard test. I just want to make sure you know the material. That's all. That's all. That's the only reason I'm giving you the test. I just want to make sure that you know your stuff. Okay, so anyway, Emma, yes, okay, can I help you? Go ahead.
Sorry. In the recorded lecture, it meant, I don't know if it's true, but it mentioned that the midterm was open book. Is that true or is that?
Well, I mean, if it's online, of course it's open book, isn't it?
Uh, yeah, no,
Right?
sorry, just asking.
Yeah, of course it's open. It's not like I'm going to go to each person's house and proctor you while you write the exam, right? Yes, it's absolutely open book. Okay. Christina,
Just
go
one
ahead.
more. I know you said that we could draw out the documents or like the diagrams by hand. Are we able to answer every question handwritten, or would you
No,
prefer it to be typed out?
it has to be Word document. Yeah. Yeah,
Okay.
you can't write it by hand. The only thing that I will allow you to write by hand, I guess I'll have to make that clear in the instructions when I post the test. But the only thing you're allowed to write by hand are the diagrams, right? Because not everybody likes using those functions in Word, right? It's sort of work intensive. So if you want, it's easier, it might be just easier to draw it by hand.
Okay,
Okay?
thank you.
Yeah. All right. Okay, everyone. So I think we're good. If you think of any other questions, just always feel free to email me. And okay, so anyway, good luck. As you know, there's no quiz, right, on Friday because of the midterm. So there won't be another quiz until the following Friday. All right, everybody, you have a great day, and good luck.